very good morning and welcome you all to this NPTEL course on electrical distribution system analysis. And today we'll be talking about basics and fundamental along with the architecture of distributions automation. Now, India currently experiencing significant increase in power demand due to growth in both industrial and to meet out the consumer's aspiration towards better life. The dependence on electric power supply has grown substantially with the increase in its demand. Now, alongside the increased demand, there is a need for having consistent power supply and also to minimize the interruptions and ensuring rapid fault restoration are the key objectives. So 24/7 power supply become a part of your developed nation, and how that can be achieved become a big question. Now, to do that, to have reliable, consistent supply system, we need to adopt distribution automation. And to meet these demands, it is crucial to adopt automation in the power distribution systems. Automation involves equipping switches and circuit breakers in control networks for remote operation, including sensors, motor drives, or actuators. Remote terminal units, that is RTUs, must be durable under extreme climatic conditions. Each location's control equipment needs a reliable power source. Now, distribution automation enables utilities to remotely monitor, coordinate, and operate the distribution network in real time. It incorporates local intelligence, data communication, supervisory control, and monitoring. Automation significantly enhances the efficiency and service quality of the distribution system. Now, organizations and institutions like CPRA Bangalore, ERIDA, CMC Hyderabad, ERDC Trivandrum, BHEL, CDAC, INTRA, IIT Chennai, IIT Kanpur, IIT Roorkee, and most of the institutions are being part of this development work in this field, including industries such as Crompton Grace Bath Electronic, Minelec Private Limited, Bhartiya Industry Limited, and including many notable Indian company and manufacturing industries are part of this automation process. Now, what are the components that constitute or form the complete distribution automation system? And the components are such as computer hardwares, essential for processing and managing data. Computer software enables control, monitoring, and data analysis. RTUs, devices which are for remote monitoring and control. Communication systems, which is vital for data transmission and connectivity. Consumer metering devices and relays for monitoring consumer loads and system protection. Now, what are the benefits of having a distribution automation? It ensures a more reliable and stable power supply, reduces interruptions and downtimes, maintains consistent voltage levels, increase efficiency and minimizes the waste, that is system loss reduction, reduces the need for extensive physical infrastructure. The major functions of distribution automation is to enhance system resilience, optimizes distribution pathways, enables oversight of distribution equipments such as transformers, capacitors, and breakers, reduces service interruptions, enhances overall customer satisfactions, more efficient operation lead to cost savings, optimizes resource utilizations. Now, what are the technical and regulatory aspects? Now, there are a bit of complexity in technical aspects, requires thorough planning and examination, includes protocols like IEC 608705, 101/104 and IEC 618504 data communication, and it also mandates compatibility with SCADA systems, includes network analysis, work management, trouble call analysis, etc. Now, distribution automation, in a typical distribution system integration, different blocks are integrated through a consumer information system. You can see that automated metering mechanism, work managements, trouble call analysis, RTUs, EMS, engineering applications, distribution management system. So they all comes under distribution system automation functionaries. Now let us understand what is automation switching controls, which includes outdoor lighting controls, line capacitor switching controls, line post sensors, faulted circuit indications, and radio switches. Outdoor lighting controls use electromagnetic or electronic thermal relays and photoelectric controls. Line capacitor switching control are managed locally by time temperature control as well as current, voltage and VAR and remote VHF and UHF radio controls. Line post sensors are for SCADA and local feeder monitoring, aiding in load switching and fault detection. Faulted circuit indications help in locating fault through LED fluorescent flags and SCADA systems. Now, moving to data concentrator, a microprocessor based unit that collect data from various SCADA devices, which acts as a gateway and essential for the AMR systems, functions as a data accumulator and communicates through different protocols like DLC, RF and GPRS. Ethernet, which is a part of important communication, so a network protocol with a 10 Mbps transfer rate using CSMA/CD to avoid collisions. Variants including IEEE 802.3, 10 base 2 thin cable, 10 base T unshielded twisted pair wing, and 10 broad 36 long distance Ethernets. Information technology in power systems encompasses both administrative and technical computing, involves smart devices for power generation and distribution automation, including SCADA and EMS. Intelligent electronic devices, IED, microprocessor equipped devices that can send, receive data externally, used in substation automation and can enhance operational efficiencies, and LAN, which connect computers and peripherals within a limited area of resource sharing. Management information system, which is responsible for administrative computing system in the power utility industry. Human machine interface, the interface between human operators and technological system for process control, which also integrates with RTUs for data acquisition and system control. Modem, which is a very common device for modulating and demodulating digital data for transmission over communication links, operates at various speed and may integrate with RTUs. Packet switching involves sending data blocks over a network with each packet containing sender, receiver, and error control informations. Efficient for data transmission and governed by the CCITT X.25 standards. Programmable logic controllers, PLCs, control devices with programmable microprocessors, used for substation remote operation and communicates with RTUs. And we use different protocols to set for rules for syntax, semantics, and synchronization in communication can be implemented in hardware, software, or both. Routers are used for, as a networking device that directs packets to correct LAN segments. RTUs, they are microprocessor based devices in substation for data acquisition and transfer, monitor various electrical parameters and communicate with master stations. Workstation, which is a high performance computer acting as an interface to databases, used in GIS, CAD, CAD, PFMS for managing transmission and distribution data. Now, there are few architectures for your WAN, wide area networks, as you could see, connect users over large geographic areas, often spanning cities or states. Now, communication, which play a very important role within your distribution automation system. And communication systems are indispensable in managing and operating electrical grids, enabling efficient data transfer between distribution control centers and various network points. Effective communication infrastructure planning necessitates considering factors such as average message rate, data handling capacity, system responsiveness, and scalability for future network expansion and application integrations. Different communication technologies and topologies, and the system predominantly utilize master slave and peer to peer communication technologies, employing physical topologies like star ring or mesh and bus, which can be tailored to specific network requirements. PSTN, Public Switch Telephone Network, which employs dial-up and dedicated lease lines, suitable for distribution automation and automatic meter reading, that is AMR, supports two-way communication initiated by metering equipment or central stations. Powerline Carrier (PLC) utilizes the existing power network, extending to newly added network elements, has limited bandwidth, typically less than 100 bits per second, ideal for consumer load management and AMRs. Ripple Control, a remote control system that uses audio frequency signals, employed by over 1,000 utilities worldwide. Signals characterized by interval between impulses, controlling remotely connected relays. Cyclocontrol, which is a remotely control achieved by altering supply waveform cycles, used for controlling street lighting and other loads. Tata Power in Mumbai and Karnataka Electricity Board in Bangalore use such cyclocontrollers. Carrier frequency, a narrowband system on high voltage transmission lines. Frequencies range from 9 to 500 kHz with data rates less than 100 kbps, used for control of switchgear, telephone systems, and line protections. Distribution line carrier (DLC), a high-speed narrowband system for medium and low voltage network. Frequencies ranges from 5 to 150 kHz, compliant with IEC standards suitable for SCADA and AMRs. Broadband over power lines, that is BPL, provides broadband internet access through power lines, operates in the 2 to 35 MHz frequency range, enables advanced meter management, asset monitoring, and remote workforce management. Low speed power line technologies include systems like Loanworks, PowerBus, operates in the narrowband frequency range, that is 9 to 148.5 kHz, used for home and building automation. Radio communication technologies includes Zigbee, Wi-Fi, WiMAX, and UHF, VHF radios, used for high-speed independent data communication, essential for areas where power system conditions are unstable. We do have similarly different radio communications, and the range of radio technologies. Radio communication encompasses several technologies like Zigbee, IEEE 802.15.4, Wi-Fi IEEE 802.11b, and WiMAX IEEE 802.16m, each offering different ranges, speeds, and frequency bands. These systems are typically owned by utilities and operate independently from the power systems. Specific applications and licensing, various radio frequencies including UHF and VHF bands are used for different applications like SCADA, distribution automation and meter reading, licensing for specific frequency slots such as 66 to 68 MHz, 136 to 174 MHz in VHF, and 314 to 367 MHz, 585 to 622 MHz, 915 to 935 MHz in UHF is often required. Different radio communications and their different types of radio communication: UHF point-to-point radio, UHF multi-address system radio, VHF radio, packet switching networks, as well as cellular radio are different subtypes of radio communications. Now, one of the communication architecture typically for UHF multi-address radio system MAS, you can see the architecture how it look like, and typical packet radio UHF radio for WAN and distribution line carrier DLCs. This is how the model architecture look like. Typical architecture of the cellular radio HF 915 MHz WAN network and its architecture. And also we can think of fiber optics is one of the power communication carrier, provides high data rates and is immune to noise and electrical interfaces. Widely used for trunk routes in power transmission lines, offers broad bandwidth and low attenuation. We also use satellite communication, employs VSAT network for power systems, features high reliability and is effective over long distances, suitable for load management, control and remote monitoring. Now, typical fiber optic communication system for underground distribution system for metropolitan areas are being designed in such a manner. Schematic diagram of VSAT network, and one of the important component is known as sensor in our distribution automation system. Sensors in electrical systems are integral for real-time monitoring and control. They are deployed in various components like substations, metering, switch gears, transformers and communication nodes. Data acquisition, which mainly collect crucial data such as phase currents, voltages and detect fault like short circuits and grounding issues. This data is essential for isolating faulted sections and monitoring system health. Now, sensors, the major applications include devices like current transformer, voltage transformer, level gauges, pressure gauges and temperature elements. Optical sensors are used for measuring high fault currents accurately without any saturation issues. Now, different components of sensors like your transmitter, transducers and receivers. I suggest all of you to get into the details of those components to understand more about the sensors applications. And finally, the supervisory control and data acquisition, which is SCADA systems. Now, there are different applications of SCADA systems. Small SCADA systems for limited functions in distribution network and industrial complexes. Medium-sized SCADA and EMS for distribution, sub-transmission networks and some generation functions. And finally, the large-scale SCADA and EMS for extensive functions in transmission network and generation. Different component of SCADA systems includes human-machine interface, workstation, servers, communication subsystems, peripherals and RTUs. Components communicate via a local area network LAN using standardized protocols. Flexible redundancy with hot standby server for time critical functions. Now, the hardware and software aspects. The hardware comprises user-friendly interfaces, workstation function-specific servers, communication system and peripherals. Whereas the software requires understanding of packages, operating systems, database access and system integration. Relies on experienced in-house group or external services for maintenance and enhancement of application programs. The system architecture, in case of the modern SCADA system, trend towards open system architecture, and open architecture allows functional integration of equipments from different manufacturers, interoperability, adherence to standards like OSI model is crucial for system longevity and vendor independent evolutions. Distributed architecture enhances flexibility for system extension and upgrades. Now, the interface and RTU considerations. When interfacing RTUs to existing equipments, considerations including availability of contacts, motor drives, PLCs, IEDs, RTUs, meters, relays, wiring and power supplies. Measurement transducers and interposing relays may also be required. Distributed configuration in SCADA that the regional centers manage subset of RTUs and perform associated SCADA functions. Dispatch centers can assume control of RTUs during regional center failures. Modern RTUs feature distributed architecture with I/O processing through distributed nodes connected by LAN. So the typical SCADA system components, which has been given in the following figure, I suggest everyone to carefully go through it. And the Consumer Information Services CIS. In India, mainly the consumer services in the energy sector are predominantly complaint based with a focus on fast, accurate, and cost effective service delivery. So, the consumer information service application customization is an important challenge where CIS applications are typically utility specific, requiring either in house development or extensive customization of standard packaging. Field service managements, which includes scheduling and execution of consumer service request, assignment of personnel, dispatching work team, and tracking service order progress. Workflow management in CIS, which involves routing, analyzing, and distributing work to appropriate entities within the system for efficient handling of various activities. Support and technology integration. CIS incorporates extensive online help system and integrate with telephone technology for effective help desk operations. Now, the core function of any consumer information services is to manage it properly, accounting, service order, field service, new business processing, and finally the meter reading, which also includes service rate administration, billing, accounting receivables, credit, deposit and budget, collections, workflow management, and website managements. The Geographic Information System GIS, which takes care of your asset management and network visualization. Operational application and digitalization is possible through GIS. Integration with business support and advanced applications can also be carried out through the GIS infrastructure. And automatic meter reading, which is an important component of your distribution automation system and SCADA. The major benefit of AMR is to automate the collection of consumption data from power utility meters via telephone lines, radio systems, or power line carriers. It enhances billing accuracy, eliminates the need for manual meter reading, shortens the billing and payment cycles, improves load management, detects tampering and leakage early, increases ROI on meters, and enables remote connection, disconnection in power. The key components of AMR system comprises automatic meter reading, a communication link between meter and the central billing system, and a centralized database for consumption data. Meters are equipped with transmitter receiver modules for communication via PSTN, cellular, GSM, GPRS, or PLC. Radio technology with varying frequency band based on regional regulations is the predominant communication method for AMR, offering a cost effectiveness and widespread coverage. Now, technology implementation and additional features, because it's ever growing area. In regions like the US, spread spectrum modulation is used due to the shared radio band. Environmental factors may necessitate the use of repeaters, especially in high density area or buildings with structural barriers. AMR softwares not only manages meter readings but also supervise operational conditions, detect fraud attempts, and analyzes consumer load profiles, adhering to standards like IEC 62056 for meter reading and data exchange. Distribution automation system components, which is a master station with workstation, communication equipments, and console or HMIs. Feeder automation components includes RTUs, SF6 gas switches, line sensors, and communication media. Consumer automation equipment such as RTUs for transformer and consumers along with communication media. Communication methods for SCADA systems. Telecommunication, that is twisted pair cable or coaxial cable suitable for semi-urban areas with data rates of 600 to 1200 bps, short interruption times and medium cost. Radio communication ideal for rural areas with similar data rates but longer interruptions time and lower cost. Fiber optic communication preferred in urban areas offering high data rates of 1 Mbps, very short interruption times and higher cost. So this is how you can see master station network architecture, the typical network for master station, which comprises multiple workstations connected with Ethernet, LAN, with gateways, bridges, and modern interfacing with RTUs. Takes such as data management, network monitoring calculations, maintenance, and mappings are distributed along various workstations. Remote control load management for different applications, including agriculture. Implementations are quite important. REC approved schemes for remote controlling agriculture load have been introduced in Indian states such as Punjab, Haryana, and Rajasthan. Radio frequencies, that is 849.05 megahertz and 933.05 megahertz, are used for signal transmission and reception. Turnkey projects by CMC with maintenance contract demonstrate the successful deployment of these systems. So the typical distribution automation system, you can see we do have a SCADA systems and total distribution automation system, substations, master stations, and in case of overhead lines and underground lines, and we have communication media from each case. So probably the typical distribution automation system architecture look like this. And with this note, we come to an end of today's lecture. Thank you very much for your kind attention.